Okay, hello, our names are Ella Lesnever and Madeleine Harbison, and today we will be talking about Earth's early history.
This is our table of contents. Our presentation is divided into 3 groups, with each group having its own claim, evidence, and reasoning.
Introduction. In this presentation, we will be explaining about Earth's early history. Some of the topics that we cover are the composition of Earth's oldest rocks, radiometric dating, the sizes of impact craters on Earth and throughout the solar system, the activity of plate tectonics and surface processes, and how the Earth has changed over time. Now, let's move on to the presentation.
Group 1. Group 1 will be explaining the age and composition of the Earth and some of its rocks. Claim. Our claim is that the Earth is over 4.3 billion years old.
The evidence to support our claim is that there have been rocks found on every continent of the Earth that are found to be over 3.5 billion years old. We know the Earth is much older than this because of plate tectonics and erosion. The surface of the Earth is changing constantly. We will explain a bit more about that later. Some other things that have been found to show the age of the Earth are zircon crystals that were found in Australia, which have radiometric ages of 4.3 billion years. Zircon crystals aren't technically rocks, but do last a long time and are some of the oldest things on Earth. Finally, there have been moon rocks that are dated between 4.4 and 4.5 billion years, which shows a probable age of the moon. This helps with figuring out the age of the Earth because the moon was created by debris left over from the creation of the Earth, meaning that the Earth is close to or a little bit older than the moon.
Here is some of the reasoning behind our claim. Radiometric dating is used to identify the age of the different rocks on Earth and the moon. This is a process where scientists study the elements in the rocks and observe how much they have changed over time. All the elements have half-lives, which is the length of time it takes for them to change into a different element. A common type of radiometric dating is the potassium isotope, where they observe the change from potassium to argon. Depending on how much the element has changed from potassium to argon is how old the rock is. Also, it is thought that all the planets in the solar system are around the same age, so because of this, Earth would probably be a similar age. As well as figuring out the ages of the other planets that don't have as much erosion to figure out how old they are, there have been a few rocks found in Canada which are believed to be part of the Earth's original crust, which would make those the oldest rocks left on Earth.
Group 2. The second group in Earth's early history is about the bombardment period. For this group, we made the claim that when the planets first formed, around roughly 4.3 billion years ago, there were many meteors in space causing the Earth as well as the other planets to get bombarded. Because of this bombardment period, there are many craters on the Earth and all of the other solid planets that are around the same age.
Evidence. Our main piece of evidence to support the claim is that there are craters and meteorites found on every planet that are all around the same age. These craters come in many shapes and sizes, but they are all impact craters created by meteors. Even the Earth has lots of craters, except they are harder to see because we have lots of life on Earth that changes the ground every day. In the picture on the left, we see the surface of Mercury, the planet in the solar system with the most craters. Even though these craters look small in the picture, they are some of the biggest craters that are known to man. The arrows in the picture are actually pointing to the ridge of a larger crater that has been eroded away, but has many craters inside of it.
Here's our reasoning for why we knew there was a bombardment period and how we know. We know that there was a bombardment period in our solar system because most of the craters found on all of the solid planets are found to be around the same age. With radiometric dating, scientists can see how some of the elements in the rocks have gone through half-life cycles to become other elements. Since some of the same elements are found on all planets, we know the craters are around the same age by the amount of half-life cycles that have happened in each one of them. When the planets were forming, there was lots of loose matter floating around in space, which eventually became meteors and crashed into the planets, creating craters.
Group 3. The final group in our presentation is about plate tectonics and surface processes on Earth. We will explain how these processes affect the terrain and craters on Earth. We claim that the Earth's terrain changes over time due to erosion, weathering, and plate tectonics.
Our evidence is that the Grand Canyon was once known to be much smaller, but has gotten bigger because the Colorado River has eroded the inside away, making it deeper. Mountains are formed due to shifting plate tectonics. Vredefort crater found in Johannesburg, South Africa, was once 140 kilometers wide when it first formed, but because of erosion, this crater appears to be only 80 kilometers wide. Weathering and erosion cause land and rocks to deteriorate, but can often also move rocks, causing the appearance of different things to shift.
Plate tectonics cause the crust of Earth to constantly shift, melt, change, and recycle itself into a new crust. At the area where the tectonic plates meet, mountains can form where they collide, valleys can form where they are pulling apart, and the crust can melt and recycle when the tectonic plates go over top of each other. Because the tectonic plates are always moving, the Earth is always changing. And since some of these craters are multiple billion years old, lots of them have changed with the Earth, making some of them disappear or change since they have been created. As well as plate tectonics, erosion is a big factor for why the Earth is constantly changing. The wind, water, and weather are eroding the rocks away, making the impact craters disappear or get filled with other rocks. This shows why most of the rocks on Earth are much younger than the Earth itself, and why it is almost impossible to find a piece of Earth that hasn't changed from its original state.
Both Ella and I wrote a reflection about the cross-cutting concepts of stability and change, and what these concepts meant to us. Now we are going to read them to you.
Both stability and change are very important in our everyday lives and in the natural processes of the Earth. Because of this assignment, I have started to think about how much the Earth and the planets in our solar system are changing at all times. Some of the ways that Earth is changing is through plate tectonics and erosion. Both of these change the appearance of the Earth. This is a good thing because sometimes the older things on the Earth need to be taken down or destroyed or changed so that the area can be healthy and fresh. On the other hand, stability is also a good thing. If nothing had changed in our Earth over the years, it would look the same, but then it would be much easier to identify the age of our planet and some of the things around us. As well as that, nothing would have changed, meaning that we would be able to look right into the past.
Stability and change appear often in our lives. This assignment has caused me to think more about explanations for things in my life that remain stable and also things that change. An example of this is when my dad takes me out on our porch to look at the moon and the planets through his telescope. The sky is always changing, and science helps people figure out why. Changes made to the Earth by time can be both good and bad. Change is important because it can help new things rise. Change can be difficult sometimes because it can bury once was and make it more difficult for scientists to discover things about the past of the Earth.
In this presentation, we talked about the age of the Earth is over 4.3 billion years old. Zircon crystals that were found in rocks that have radiometric ages are discovered to be up to 4.3 billion years old. Scientists discovered the probable age of the solar system, and they make an estimate that is close to Earth's age, assuming they were created around the same time. When the planets first formed, there were many meteors in space, causing a bombardment period and lots of craters on all of the planets in our solar system. Because of plate tectonics and erosion, some of Earth's craters have changed or disappeared.
This is our bibliography. The end.